Hello, all. We thank God for another opportunity to have a class. Let's have a short prayer as we start. Father, we thank you this time again for granting another opportunity to meet. As we go through this lecture, we pray for your guidance and help us to get all that we need to get in Jesus' name. Amen. Thank you very much. All right, so we going to consider this question on development, and it's a truncated hexagonal pyramid. It says that the hexagonal pyramid with side of base 30 millimeters and height 75 millimeters stands with its base on the horizontal plane and an edge of the base parallel to the vertical plane. An edge of its base is parallel to the vertical plane. Okay. I continue to say that it is cut by a plane perpendicular to the vertical plane, inclined at an angle of 45 degrees to the horizontal plane, and passing through the midpoint of the axis. And we are to draw the sectioned top view and develop the lateral surface of the truncated pyramid. Okay, so here we are to draw the views, the top view, draw the projection of it, and then develop the lateral surface of the truncated pyramid. Okay, some situation you may be asked to draw the projections, which are the three projections: the front view, the plan, and then the end view of this truncated pyramid, and then develop the surfaces of it. Okay, so assuming the bottom is closed, it should be part of the development. Assuming the truncated surface is also closed, we need to also add it to the development, so we go more into detail and include all those things. All right, so let's get into it. Okay, so first of all, we need to draw the projections of it, and we can start by drawing the plan. So the plan will be in the form of an hexagon, and the simplest method that we can use is by using the circle. So we inscribe the hexagon in the circle. So what you do is mainly draw a circle with radius equal to the sides of the hexagon, the hexagonal base. Okay, so in this case we're told that the size of base is 30 millimeters, so the 30 should be the radius for this circle. And then when we draw the circle, we put in the center lines. Then with the same radius 30, from that point you mark twice up and down, and then at the other side too you mark with radius 30. So these points that we have marked there will include it will be part of the vertices of the hexagon. So we draw straight lines to connect them like this. Okay, so we connect all with straight lines like that. Now remember, this is a regular polygon, it's a regular hexagon, so all the internal angles have to be the same, and then the size, the sizes has to be the same. Okay, now because C is a pyramid, we need to draw the front view. So now we have the plan. All right, we have the plan, we need to draw the front view. So we can just project from the um, plan to obtain the front view. So we draw first of all the baseline, draw the base line, then we project from the plan okay. So before we project, we need to label the vertices of this hexagon. So we started from A, B, C, D, E, F, G. So we label them. Then from that, we need to get the height of the pyramid, which is 75. Okay, so we measure the 75 and then mark it. So we determine the apex of the pyramid. Then we're going to project from the plan to the front view. So we project that point, and then the other one. All right, we have the A also projected. The D and F, D and F will coincide. So we're going to project them also. All right. So we have that. Then we also project the B engine, which will also coincide. Then from there, we also need to connect the uh, edges of the pyramid. Okay, so because hexag is a hexagonal pyramid, we need to connect the edges, which will be straight lines like diagonal, connecting the various vertices to the center of it. All right, so we need to firm it a little bit. Going to be part of the plan. Now let's call that center point O. Okay, now on the front view we can now connect all the points we have projected to the apex. So we connect to the apex, connect that one, this one too, and then we also connect this. And now we need to label them. So we have E, so D and F will also coincide there. So we have that DF and then BG, then A. Okay, then now in the question it states that there is a cutting plane, all right, which is cutting through this pyramid at a distance of half of the axis of the pyramid. So this 75 millimeters, which is the height, is less. Okay, I mean, it's not. Is something that if we divide into two, we're going to have some fraction which we cannot easily read on our with a ruler. So we need to bisect it. Okay, we have to bisect the axis of the pyramid on the front view. So you can just bisect, use the normal bisection method, and you can obtain the center point instead of measuring 37.5, which is half of the height. That 0.5 you may not be able to measure it accurately on the ruler, so we just do that. Then after that, we draw the line, which is the cutting plane, inclined at an angle of 45 degrees to the horizontal. Okay, so we draw that, and this is how the cutting plane is supposed to be. All right, now we need to firm. So we have the bottom section of it, and that is where the one we have to develop. That is the one we need to develop. So we firm them, all the lines, to indicate that this is the area of interest. Okay, all right. So after that, we need to also determine the slash surface, or the truncated surface on the plan. So we have to project from the front view to the plan to determine those points. All right, so we project the first one there, which is along the E line, project it vertically downwards. All right, then we go to the next one, which is along D and F. We project that one to vertically downward. Then the next one, which is along the BG, and then the final one along A. So we can trace and indicate each of these points. So we have those points there, this point, that one, this one, and this one there. So that point there, let's name it 1. Okay, then the other one we call it 2, this one 3, that one is 4, and this one is 5, then this one we call it 6. Now we can draw straight line to connect these points. All right, so we can have that will give us the truncated surface. So you connect them, so that will be the truncated surface on the plan. On the plan. All right, so from here we need to firm all the main outlines, right, with continuous thick line to indicate our area of interest. So we firm all of them. We firm all like that. Now we need to shade the surface because it has been sectioned or truncated, chopped off. We have to section that surface to show that that is the area or the surface that has been truncated. Okay, so we section it, and we can just use our set square to draw lines inclined at 45 degrees, all right, to indicate the section surface. Okay, so this is the complete plan. This is the complete plan. So now we need to also label the top. Okay, so we have one, we need to label one, then we also have two, and then the 2 and 6 are in line, so they will be on the same point. So we have 2, and then 3, 5, then finally 4. We use prime, so 1 prime, 2 prime, 6 prime, 3 prime, 5 prime, and 4 prime to indicate those points on the front view. All right, so assuming this is we are to draw the end view as well, then we can project. Okay, we can project from the plan and the front view to determine the end view of this truncated uh, pyramid. So the end view, we just project from the front view and the plan. So we project this point, that point, and then we also project this one. So because this along the center, we project that upwards, and on that we are going to determine the apex of the pyramid. Right, so the apex is determined by projecting that apex on the front view to the um, end view. So here on the front view we have O prime, so here we make it O prime prime, then we connect the other point to the apex, so we have those ones. We have this one too connected to the apex, so that's the main outline for the end view. Now we need to label it. By labeling, I realized that here I made a mistake. All right, when I was labeling, the C is not supposed to be at the center there, so the labeling has to be done again. So we have A, B, and then C will be at this point. Then we have D, E, and F. Then we also need to make amends to the labeling we've done on the front view. Okay, so we have that point to be D, F, D, B prime, F prime. Then we have C prime, E prime, and then we also have D prime. All right, so at the center there we're going to have A, because it's a reflection of A and D. So A prime prime, D prime prime. Then we also have E prime prime, F prime prime from that point, and at this point we have B prime prime and C prime prime. All right, now we need to project the other points, the point on the truncated surface from the front view to the end view. All right, so when we are projecting it horizontally. So this you can use your t-square to do. I am using the set square, the ruler, to ensure that I have horizontal line. So project the one. Okay, go to the next one, which is 2 and 6. We project that one too. Then the next one, 3, 5. Then we have 4. Right, so 1 is along the middle line. So 1, we can determine 1 there at that point along A, 1 and A. So we have 1 prime prime. Then we also have at this point we have 6 prime prime. Then 6 prime prime is along the same path as 2. So we have 2 prime prime at this other side. Then this side we're going to have we need to have the 5 prime prime here, and then the other side should be 3 prime prime. Then the last one will be the 4, which is along 4 and D. So we have that one there too. Now we connect all these points with straight lines, and that will give us the truncated surface on the end view. So you connect all like this. And then we connect this one too. We need to firm all the main outline. Again, to indicate our area of interest, so the rest are not part of it. Then we need to shade, we need to hatch the truncated surface. So hatch the truncated surface like this, and that completes the end view. And there's another thing that we need to do, which is to determine the true shape of the truncated surface. Alright, so all these views we are having about the truncated surface, these views like the one on the end view and on the plan, it doesn't give us the true shape, okay, but we can determine the true shape of the truncated surface. So assuming we've been asked to determine that, though we're not asked in the question, but assuming we are to determine the true shape, how do we go about it? So let's look at how to do that. So what we do first is to project these points that we have on the truncated surface on the front view. You draw projection lines at an angle of 90 degrees to the truncated surface, okay. So we draw lines perpendicular to the cutting plane line from each of the points located on the cutting plane. So we have to draw perpendicular line from 1, 2, 6, 3, 5, and 4. Alright, so we have to draw like that. Alright, then from here we need to pick measurement from the plan to be able to determine the true shape. So what we are going to do is to draw a line, okay, which will be act like the center line, the horizontal line which is passing through the center of the plan. Okay, the line connecting, like the horizontal line connecting on the plan, we have A to D, or 1, 4. There is a line that goes through it. Okay, so that is the line, this line here. Okay, so we pick measurement from that. So what we do is that this line we have means that we have 1 and 4. So we pick measurement from the center there where this line we drew earlier when we were determining the cutting, the slanted, the truncated surface on the plan. We use that. So we pick the distance from that center line to the point 2 and 6. Then we mark them. So when we are on line 2, 6, we mark. We do same for 3 and 5. Pick that distance and mark. So we have this point, we 3, 5. Then we can connect it with straight lines. Okay, so this gives the true shape of the truncated surface. We also need to hatch it. Okay, we just hatch it. to indicate that that is the truncated surface. All right, so now we have all the views we need, all the information we need. Now we can continue with the development. So we have the plan, the front view, the end view, and the true shape of the truncated surface. Okay, so we can start with the development. So we measure the true length of the uh, uh, pyramid. All right, the true length is the edge, the slanted edge, the outer one. Because of the orientation of the pyramid, we can pick that one as the true length of the slanted edge of the pyramid. So we pick that distance with our compass and with our radius. We draw an arc. Right, so we connect the center of the arc to the end or the beginning of the arc. You connect the center of the arc to the beginning of the arc with a straight line. Right, so this will be the starting point for the development. So now we're going to pick the size of the base of the pyramid, which is 30. Then we'll mark it, all right, along this arc. Because it's having 6 sizes, we are going to mark 6 times. And then we connect the last end, the last point to this center of the arc, and we join all the rest to the center of the arc. All right, now we have to decide where we want to cut. Okay, where we want to cut. So we said earlier that it's usually good to, if you want to develop, to cut it at the shortest edge. So the shortest edge is the edge A1. So that is where we'll cut it from. So if you are cutting from there, then the labeling should start from that point. So we have, say, 1, 2, 3, 4, 5, 6, and then we'll end at 1. All right. Then we can connect all these points with straight lines. All right, so that gives the base of the pyramid. So we have the hexagon spread out. Now we need to add a truncated area too. So that one too, we need to pick measurement from the front view, okay, and mark on the development. So what you do is that we need to determine the true length of each of these points from the apex of the pyramid. So pick the measurement from O prime, and it should be along the lines, either the outer ones, okay, because we have done projection already when we're doing the front, we don't have to project to it, so we pick from the projection. So for instance, we have O prime to O prime prime to 4 prime prime. Pick that distance with your compass. Then from O on the development we mark. Right, this the base have to be labeled with letters. So let me change that, so we have that one. So over here we pick the distance O prime prime to 4. Then we mark along 4 from the center. Then the next one is O prime prime to 5 prime prime and 3 prime prime. So we mark these two on their respective positions. So this one should be 3 3 prime prime, then and 5. This one should be 3 and that one should be 5. The next one is uh, 2 and 6. 2 and 6, so we pick that distance. Alright, which is the one we have projected from 2 6 to that line. So pick that one. Then we mark there. So we have this one to be 2 and that is 6. Then the last one is up to where the 1 is. So we pick that distance too. Mark on 1 and then that one. So we have 1 and 1. Okay, so you see that it corresponds 1 and A, 2B, 3C, 4D, and the others. We connect all these points with straight lines. Okay, so these straight lines here, as we connect them also, it represents the line. Okay, the lines that is making up the truncated surface. So those are the lines we have here. Right, so with this, we finish connecting them, we see that we have the development of the pyramid. We need to firm the main outline again, so we have to firm them very well to differentiate them from the other lines, because these are the lines that we are interested in. Okay, all right, so this is what we have. The next thing is to add the base. So assuming the base is closed, we need to draw hexagon, okay, attached to the development to indicate the base. So we will decide where we want to place that hexagon, and it should be a regular hexagon. Okay, a regular one. You can decide to place it at anywhere that you want, but let's place it between, let's say, D and B, or between D and C. Let's say D and C. Sorry, if it is D and C, we can place it there, or DE, we can place it there. So if you are placing between D and E, it means that we are drawing a regular hexagon there. And the method I'm using is by using the external angle of the hexagon, which is 60. So the external angle one is 60 degrees. So I draw a line inclined at an angle of 60 to the line DE. Okay, then the other side to another line inclined at an angle of 60 to the line DE at the other side. Remember, the distance DE is 30 millimeters, equals the size of the size of the side of the hexagon. All right, so here I'm just using the 60-degree set square. to draw with the help of the 45-degree set square. So on these two lines, we need now to measure the distance, which is the size of the hexagon. So pick that distance and mark it along this line. Mark it along the other line too. Now we have 2 points. Okay. At these 2 points now, we have to move to each of them. Then we trace the other ones. So from the next point here, I need to draw another line which should be inclined at an angle of 60 degrees, okay, to the line coming from D. So I draw that one. Then from here, I just measure the distance 30. Okay, then I mark. Then from that point, I don't need to draw. I can just use the compass with the radius 30 from the end of point there to draw two arcs that will intersect. Then I will connect the ends of these lines to that point of intersection. And this will be a regular hexagon with all the sizes equal and all the angles inside equal. So I firm in the main outline. Then from here I can label them. So label, so that point you see this is B, A, then the other side will be F. Alright, now we need to add the true shape of the truncated area. We need to add it to it. So what is going to be done here mainly is to transfer. I'll just transfer that shape that we have the true shape to the development. So in transferring, I have to decide where to place the truncated surface. So I can decide to place it between 1, 6, 1, 2, or any other place. Okay, between 2, 3, or whatever. Between 3 and 4, any other place that you want to place it, but it has to flow. And you realize that if I measure the distance on the true shape, 2, 3 is the same as 2, 3 on the development. The size is the same, which is the same as 6 and 5. If I measure 1, 2, the same as 1, 2 on the development. Okay. So if I'm transferring, I can decide which side of the true shape I want to start drawing with. So I can decide I want to start with 1, 2. Okay, so along line 1, 2 means that 1, 2 representing one side of the true shape. So I can, from there, I can add the other sides of it. So I just use the compass to pick the measurements from the true shape. Then I will just transfer it to the development. So here I pick the distance from 1 to, so it should be from 1 to 2 is the same as from 1 to 6. Okay, but I will need the distance from 1 to 2. So I pick that distance. Sorry, it has to be from 2 to 3. Yes, 2 to 3. Because I have 1, I have 2 already, so I need 3. So 2 to 3, I pick that distance from the true shape and then draw an arc. From 2, I draw an arc. Then from 1, I open the compass to 3. that distance. Then when I come to 1 on the development, I draw another arc to intersect with the first one. Okay, so where it will, the two arcs will intersect, it will be the point 3. That will be 3. Okay, so I have to just draw a line from that point to the point 2. So I have line 2, 3 now. Now the next one is to, let's say, determine 6. So I measure 1 to 6 from the true shape and then draw an arc from 1. Okay, so I draw an arc. Then I have to be at, say, 2. At 2, I measure the distance from 2 to 6. So we have 6 there. So that one is supposed to be 2 to 6, not 2 to 5. Okay. So I pick the distance 2 from that 6 up to, now I need to determine 5. So I measure 6 to 5. Then from 3, I already have 3. So 3 to 5, pick that distance 2. Then from 3, I draw an arc to intersect. So I obtain 5. So I draw a line from 6 to 5. Okay. Then I'm left with the last one, which is 4. So from 5, I open to 4, draw an arc. Then from 3, I draw another arc to intersect. So I have that one. So that is 4.